Hello, I'm Bong-gil Park. My work in Samsung is to develop software solutions to run HDR10 Plus ecosystems for both video and games. I'm joining you today to provide an overview of the latest developments in HDR technology and how Samsung is innovating to deliver the best quality for all the video game lovers in the world. Let's get started. Have you ever tried taking pictures of people in front of something really bright? Think of the sunset in the evenings or a shining sun in the middle of a summer day. Something like this or that. It's not a recipe for a photographic success. Instead, you usually end up with a dark silhouetted figure framed by a bright backdrop. Now, how about this one? This looks much better to me and making me feel even more comfortable. But why? It's all about how familiar each picture is to your real-life experience. In real life, we know that we can always read people's face even if there's a bright sunshine behind them. Yes, the new picture is similar to what we always expect in everyday life, and this makes us feel comfortable. But how are we able to see things like the new picture in real life instead of the others? The answer is because our eyes are and have long been operational as high dynamic range, or HDR, for our basic survival. In the world we live, the contrast or the dynamic range between the brightest white and the darkest black is about 1 trillion, which is roughly 1,000,000 times bigger than what our eyes can handle before adaptation. For example, the direct sunlight during the daytime is about 1,000,000 nits, while a star in midnight is just 1,000,000th of a nit. Human visual system has to find ways to see things under such a dynamically changing environment. And as we know, it does the job fantastically. In the beginning, when we started our research on the HDR technology, experts in Samsung and Hollywood studios have slowly realized that what we were trying to find at that time was something human visual system has achieved during the long history of evolution. So, we've studied how our vision works. Human vision is a continuous process, operating mainly within eyes and brain to capture lights and construct a sequence of mental images of the world we see. Imagine the situation where you're standing on a beach with your loved ones in front of a beautiful sunset. You first look at the red-colored sun shining above the horizon. Then you move your eyes to the person standing ahead of you and give a smile. The photoreceptors on your retina have limited dynamic range, so your eyelids and pupils have to adjust the amount of light reaching the retina, depending on the absolute brightness of the things you look at. Without such an adjustment at the eyelids and pupils, the actual visual information delivered to the brain would be blurred away. So, while looking at the sun, you squeeze your pupils, and when you switch your gaze to the person's face in front, you open up your pupils and eyelids. From both the gazes, you collect maximum possible visual information from the sun and the person's face respectively. Then at the final step, you construct the mental image of the scene in your brain, which looks like the one on the right side. But this is not the end. Your brain remembers the striking look of the shining sun which was too bright to look at. For this, you label the sky as dazzling and add it to your mental image of the scene. So, seeing is a process, continuously building mental images of the world, having intelligible visual information plus emotions related. HDR video was created to allow creatives to produce images that exceed the dynamic range of adapted human vision and create a very striking image that looks real and very dimensional. This is best seen on reference monitors and high-quality HDR displays such as the Samsung Onyx and high-contrast Neo QLED displays. With these displays, the creative intent of most of the HDR videos can be preserved 100% with the intelligible visual information and the emotions fully reproduced exactly as the original. Sometimes the dynamic range of HDR videos may exceed the capability of a given television. For this, the HDR10 Plus system was designed to adjust the dynamic range to utilize only the maximum capability of the display. But still, compliant HDR10 Plus displays can preserve the original creative intent very well because certified televisions have more dynamic range than the adapted human vision. Conceptually, HDR10 Plus display tone mapping is a simple two-step process. Technically, we call these as basis OOTF tone mapping and guided OOTF tone mapping. But today, I want to call them as peak matching and selective mapping. First, for the peak matching, there can be two cases. Content peak brightness may be, number one, within the display peak, or number two, beyond the display peak. When the content peak is within the display peak, tone mapping is unnecessary because there's no brighter pixel than the display's capability. So, pixels in the content domain will be rendered on screen exactly as they are. Mission complete. On the other hand, when the content peak is brighter than the display's max luminance capability, HDR10 Plus simply renders the brightest pixels in the content as the max luminance of the display. By the peak matching in HDR10 Plus, content creators are guaranteed to drive the display up to the maximum physical brightness possible whenever needed. Then the second step is selective mapping. During the selective mapping, HDR10 Plus display interprets tone mapping metadata frame by frame. Each tone mapping metadata defines luminance offsets and contrasts for multiple brightness ranges up to maximum 10. As a result, during the selective mapping process, HDR10 Plus displays may independently treat tone mappings for multiple objects having different brightness. Such an aspect of the HDR10 Plus selective mapping, combined with peak matching, preserves the tone and appearance of the image as well as still presenting an HDR look to the viewer with more dynamic range than their adapted vision. So, through the HDR10 Plus process, not only the intelligible visual information, but also the emotions in the mental image at the creation stage are faithfully delivered to the end users across displays having different capabilities. Samsung has been committed to the development and promotion of HDR10 Plus technology from as early as 2017. HDR10 Plus is a royalty-free, open standard, open to any business entity selling products and services based on the technology. The HDR10 Plus standard has robust support across the industry. First, all UHD TVs and 4K projectors from Samsung after 2017 support HDR10 Plus. And we have more than 4,800 different certified devices from total 26 manufacturers worldwide, including TVs, projectors, smartphones, tablets, soundbars, and to name a few. When it comes to user-generated content, YouTube supports HDR10 Plus, one of the premier video processing technologies. So, HDR10 Plus is now providing content creators and viewers alike with a unique opportunity to have the access to enhanced premium HDR content right at their fingertips. Today, Samsung is introducing a new HDR10 Plus extension for video gaming. According to the recent survey, the total number of video gamers worldwide was roughly 2.8 billion by the end of 2020. And the number is expected to grow very quickly over the years to come. So, as one of the world's biggest TV suppliers, Samsung had to think very seriously about how to make our valued customer experience a great one in playing video games. Our answer to this particular question is the new HDR10 Plus extension for gaming. As previously explained, HDR10 Plus is one of the latest dynamic HDR technologies that makes the strongest possible highlight effect with more dynamic range than the adapted human vision. The new HDR10 Plus for gaming also provides the same picture quality benefit to the gamers. But this is not enough for video games because there are a couple extra features needed critically for a perfect gameplay. They are variable refresh rates, automated HDR calibration, and low latency source to mappings. First, let's talk about the frame rates. Different applications use different frame rates. As shown in the diagram, video contents use fixed frame rates between 24 to 60 Hz, but gaming contents use variable refresh rates between 30 to 120 or sometimes higher than that. You may wonder why games need higher frame rates than video content. Or others may question why games need even variable refresh rates. This video illustrates the impact of using different frame rates for video contents like movies and drama. The clock on the left is running at constant 30 FPS, and the one on the right is running at constant 15 FPS. But as you see, the visual difference is very little, so little that you can hardly recognize it unless you keep looking at the green ball at the bottom right. For video content, regardless of the frame rate chosen, as long as the capturing rate is kept constant, playing it at a constant frame rate will produce a smooth presentation of the captured motions. Now, let's watch another video. This video illustrates the potential visual impact of a poor graphics flow control in a video gaming system. Let me explain how such problem occurs. In video games, rendering time varies frame by frame in an unpredictable manner. The reason is because each frame has different complexity, and each frame's complexity is a function of unpredictable user inputs. Now, let's connect a display to the video output of the gaming machine. But unfortunately, the display is running at a fixed rate. You see, there's a mismatch between the frames coming out of the gaming machine and the timing that the display consumes them. We may try increasing the refresh rate of the display, for example, by twice. This can partially improve the situation a little bit, but still, the frames coming out and the frames consumed cannot be matched perfectly, as you see on the right side of the clock animation. This is the solution. But how can we make it happen? We need two things in the display device. Number one, the display has to have a peak refresh rate, which is higher than the fastest output rate of the graphics engine. Number two, the display has to render every incoming frame within a very short fixed interval, which is almost 0 seconds. This is the functional definition of variable refresh rate technology. And this feature is available from select HDR10 Plus gaming TVs and displays next year, up to 120 Hz. The second important feature of HDR10 Plus gaming extension is automatic HDR calibration. We know gamers are familiar with settings and configurations of all kinds. They are experts on finding optimal settings for their game machines and displays against a collection of favorite game titles. But having to switch between different configurations, title by title, is still a big waste of time for anyone. So, we've decided to help gamers with this particular problem as part of our HDR10 Plus gaming extension. Those who have tried playing HDR games at home must be familiar with the settings. This is what is typically called Hdr Display Calibration. And doing the calibration is not a difficult task because the step-by-step interactive guide is so well organized. But doing this is apparently less fun than immediately jumping into the game without doing such a work. HDR10 Plus gaming extension and the corresponding certification program includes test procedures and rules to verify handshaking process between source and display devices. During the handshaking, a display provides its panel properties to the game's HDR10 Plus processing block. On receiving the physical attributes from the display, the game automatically performs its HDR10 Plus video output optimization for the given display without the user having to do it manually. This process is not only convenient, but also very effectively preserves the original creative intent of the game creators. Now, it's time to talk about latency. What is latency? And why it matters in video games. Let's imagine that you are playing a classic casual game with a yellow little bird jumping upwards according to your key presses. Actually, this is the last hurdle before clearing the stage. Looks like a piece of cake. You press the button on seeing the little bird touching the top of the trees far away. But against your expectation, the poor little one keeps falling down for a couple more milliseconds to touch the ground, making you fail once again right before the end of the final stage. This explains well why latency is so much important in games. One of the goals when we designed the HDR10 Plus gaming extension was to make the extra latency zero. So, both for the cloud scenarios and local game machine scenarios, we've separately developed zero latency architectures for our HDR10 Plus gaming tone mapping processes. Samsung is now taking steps towards making the zero latency HDR10 Plus gaming tone mapping technology available through the new HDR10 Plus standard. With the new dynamic tone mapping architecture, owners of our certified HDR10 Plus game displays will be able to enjoy a latency-free HDR gameplay experience. Samsung's vision with HDR10 Plus is to make our valued customers happy with premium picture quality across all the different applications where our products and services are used. Guided by this vision, Samsung will keep working on research and development of new technologies in the world of HDR, with HDR10 Plus at the center of the action. Thank you.